Hi everyone, we continue revision on chapter 5, electronics. Okay, let's look at paper 1, objective question. Okay, number 1, diagram 1, the process of electrons escaping from the surface of heated metal. As we know that metal, below the surface there are a lot of free electrons. When heat is applied, electron will gain energy, and when the energy is enough, it able to release itself from the surface of metal. So this process, because there is a heat that absorb and becoming kinetic energy for the electron. So this process we call it thermionic emission. Okay. Okay. What is this process? So we have the answer will be A, thermionic emission. Thermionic means refer to heat. Therma, thermionic, therma. Therma means heat. Okay, number 2. In a cathode ray tube, the potential difference across anode and cathode is 500 volt. What is maximum velocity of electron when it reaches the anode? Kinetic energy gained by one electron, half mv squared, is equals to potential energy supplied by the EHT, or potential difference, EV. Okay, where does this one come from? From the formula or definition of potential difference, which is E divided by Q. Okay, so from here you get E equals to VQ. So for this one, we just discussed for one electron, thus Q equals to charge of one electron or equals to E. That's why here become EV. Actually is QV, QV. So we just discussed for one electron. One electron just enough to represent the whole beam of electron. Okay. So you just substitute all the values. This is mass of one electron, velocity of electron, charge of one electron, and voltage of power supply. So half 9.1 10 to the power of negative 31 V squared equals to 1.6 10 to the power negative 19 times 500. So calculate for V squared. So we get V. Answer is C, 8250 meter second negative 1. Unit here is wrong. Should be second negative 1. Okay. So that one is the maximum velocity gained by electron. Okay, number 3. This is a Maltese cross tube. The direction of deflection is determined by, if you put a magnet here, U or north, north, south, electron is negatively charged. So you can use Fleming left-hand rule. But remember, for Fleming left-hand rule, FBI. Direction for the center finger actually represent current. So if you want to apply Fleming's left-hand rule to determine direction of the deflection for the cathode ray, you need to put it in reverse direction. For example, if current is in this direction, means electron should be here. It's opposite direction. Okay, opposite direction. So as we can see from here, this is the B, which is always pointing to south magnet, and then the current reverse direction opposite to the electron. So if you apply Fleming left hand rule, so we can see the shadow will be deflected. Above and below should be out from the screen. Okay. So this one we use Fleming left hand rule. Okay, number 4, which particle escape from the surface of metal when heated at high temperature? Electrons. Okay, thermionic emission. Number 5, this one electronic symbol representing electronic component. So you need to memorize the symbol. The big arrowhead here, this one represent P and this one represent N, means this one is PN junction. PN junction also known as diode. So this is symbol for diode. Okay. P means a positive type, N means N type. So PN junction is diode. Number 6, diagram shows EHT connected to metal plate inside cathode ray deflection tube. Based on observation diagram 5, which statement is correct? So you can see from here, EHT here is 1 kilovolt. This one is 3 kilovolt. Which one is correct? Increasing of EHT will increase deflection of the cathode ray. Increasing of EHT will decrease deflection. So when voltage across deflection tube is greater, means the electric field across the metal plates will be stronger. So means the cathode ray will be deflected more. Mean deflection will increase. So increasing EHT will increase deflection. Okay, because stronger electric field. Yeah, stronger electric field. I hope you know the definition for electric field. We'll look at 7. Diagram 5 shows electric circuit. It is found that the light emitting diode LED does not light up. Okay. LED lights up when, okay, let's check. So this is the positive terminal. This is negative PN junction diode. This is N, this is P. So you can see the N part is connected to positive. The P is connected to negative. Mean this one is reverse bias. If reverse bias, the current will be blocked by diode, mean the circuit will be broken. The LED cannot light up. In order to allow current to flow in this circuit, we need to reverse the connection of diode, or you can reverse the terminal of battery. Means we need to ensure that diode is forward bias. then only current will be flowing in the circuit and LED lights out. So there are two methods for you all to modify the circuit so that LED lights up. The diode pole is reversed, can. Okay. Or the battery pole is reversed, either one. Diode pole is reversed, can. LED, no. Battery pole is reversed, can. Both reverse cannot reverse at the same time, either one. Okay. Sorry, LED also must function as a diode. Sorry. Yeah. So you cannot reverse this one. The battery pole cannot be reversed because the diode is already connected that way. The LED. LED is light emitting diode. It's also diode. So this one also must be forward bias. Okay. So if you reverse the terminal of battery, this one will be reverse bias. So we don't want that to happen. Means we just reverse this diode only. Reverse the pole of this diode only. Terminal of battery cannot. Okay, because the light here is light emitting diode. Okay, so answer is A. Okay, number 8, diagram shows a circuit for the rectification of AC current, alternating current. So ini adalah bridge connection. Bridge connection is for full wave rectification. We can check, try and see. Which is the correct trace on the screen of CRO? Okay, let's try. Let's see, here is A and B. Here is D1, D2, D3, D4. Let's say for the first half cycle, which is positive, current flow from A to B. So A to B here, and then reach here, go to D1. Okay, and then reach here, we continue to pass through R, and then go to here, we'll reach here, we'll go to D3, cannot go to D4, and then go to B, complete. So you can see for the first half, there will be trace positive part. Okay, for the negative part, negative, current will flow from B to A. Okay, we'll start with B, from B, this direction. So reach here, it will go to D2. Okay, reach D2, cannot go D1. Okay, continue to pass through R. Okay, and then reach here, cannot go D3 because back to the same terminal, so go to D4. And then go to A. So means for this one also, you can see direction for both current that flow through R are same. Means the next also will be in the same direction. So we can see from here the negative part already rectified, become positive. So this is the output, which is DC. But remember, here we have capacitor. So if you have capacitor will smooth out the output current. So the output will be smoothed out. So what you observe is like this. Okay, is more steady than before. Okay, so the output will become like this. B. Number 8D, sorry. Okay. It's a full wave fluctuation. Ini half wave. Okay, ini full wave. Okay, number 9. Transistor. So there are two types of transistor. Transistor is made of combination of two p-n junction. If you look at direction of current like this, current always flow from positive to negative. So if flowing like this, mean here is positive, here is negative. Positive means P, negative is N. So if here is NP, means X will be P. So here is PNP. Transistor PNP. Okay, this direction. Okay, what are named for terminal XYZ? X is collector, Y is base, Z is emitter. Collector, base, emitter. Okay. Number 10, a transistor circuit. So you can see this is LDR, resistor R, and a bulb here. So there are two circuit here, base circuit, any base, any collector circuit. V1 and V2, we call it potential divider. What is reading of V2 when V1 1.5? V1 1.5, what is V2? As we know that potential divider means they share voltage. Or we can say V1 plus V2 equals to total voltage supplied. So V1 1.5 plus V2 equals to 6. Means V2 equals to 6 minus 1.5, which is 4.5 volt. Very simple question. Okay, number 11, transistor. Calculate value of RT for the circuit above. Thermistor, this is thermistor. We know that voltage across T, let's say I put as VT, there are potential divider, means VT plus V1 equals to VA. Okay, so VT plus 5 equals to 8, means VT equals to 3 volt. We want to find the value of R. Find the current that flowing through R first. Okay, so we get is 6 kilo ohm. It's not 6, 6 kilo ohm. Okay, calculate the current flow because they are potential divider. They have same current. You have voltage of Vt, which is 3 volt. So using the formula V equals to IR, find RT. I is already calculated here. So you get 6 times 10 power 3 ohm, which is 6 kilo ohm. Okay, this is B. Number 12, IB and IC experiment involving transistor. There is a graph here. What is the most appropriate relation between IC and IB based on the graph above? You can see from here is directly proportional graph. Number 13, diagram 11 shows electric circuit. What is a function of transistor in this circuit? Transistor as a switch. Okay, the function of relay here, because the lamp here requires higher voltage. The highest voltage cannot be directly connected to transistor because transistor cannot support a high current. It easily spoil. That's why the use of relay here to prevent large current flowing through the transistor and spoil the transistor. So put the relay here. Once current flow through the inductor, ini coil of wire inductor, it will be magnetized. When magnetized, it will pull the switch and close it. Means once the current flow in this circuit, it will on the switch. That means the current will flow in the second circuit. Okay, the second circuit requires higher current. Okay, so relay switch and transistor here function as automatic switch. Number 14, transistor circuit. Which of following is correct comparison between IB, IC and IE? IE is the biggest one, IB is the smallest one. Number 15, transistor circuit used to turn on 240 volt aircon. Same thing, use of relay. Which condition can turn on the aircon? Means transistor must be on in order to turn on the aircon. Okay, thermistor, when heat is detected, what happened to the resistor? Resistance of thermistor, RT, decrease. Okay, so when RT decrease, voltage across T also decrease. As we know that both here are potential divider. When voltage across thermistor decrease, voltage across R increase. And you can see R here is in the base circuit. If voltage of R increase, mean base voltage increase. When base voltage increase, okay, current will flow in the circuit. Okay, current becomes smaller because there is a limiter here to limit the base current. So the current flow in the circuit, transistor is on. When transistor is on, current flow through inductor, magnetize it, and it will close the switch, means the aircon will be on. Okay. How to turn on the thermistor? High thermistor temperature. High base voltage, yes. So answer should be 2 and 3 only. Means thermistor must detect a heat, then only increase the base voltage. Transistor is on. Okay. Means the second circuit will be on. Okay, that one is for paper 1. Now we look at paper 2, section A. Diagram shows a simple cathode ray tube. Cathode emits an electron when switch P is closed. Okay. Name the process that enables emission of electron. So the process where electron emitted from the surface of heated metal, we call it thermionic emission. State one reason why EHT is used. To produce high speed beam of cathode rays. Okay. High speed once hit the screen, coated with graphite. So the kinetic energy of electron will be converted to light. So it means the higher the speed, the brighter, okay, the light observed on the screen. Okay. When electron flow in the cathode ray tube, current produced in 5 seconds 0.01. Calculate total charge of electrons. Q equals to IT. Okay, current 0.01, 5 seconds. So we get 0.05 unit coulomb C. D1, diagram 1.2 shows incomplete path of cathode ray in electric field. So this one connect to positive, means positive. This is negative. Cathode ray is negative because electron. So it will be deflected or attracted to positive, but repelled by negative. So complete the path of ray, so means it will be deflected up. Or better we draw something like this. Because finally it will go here and hit the screen. Okay, give reason of your answer. Because cathode ray is negatively charged particle. Okay. Number 2, automatic switch will light up street lamp during night time. So function as automatic switch. Okay, there's also a lamp that requires high current. So we have relay switch here. So use of LDR, light dependent resistor. No light, R of LDR increases. Okay. So type of transistor T, look at direction of current here. Remember current is positive to negative. So mean if direction like this, here is positive, here is negative. Positive is P type, negative is N type. So if this one is PN, means above here should be N. So NPN transistor. Okay. State the function of resistant R2. R2 is to limit base current because Okay, if the current is too large, it will spoil the transistor. Okay, to limit the base current. Okay, as we know that the base part is a very thin layer, okay, of junction. So it just requires small amount of charge in order to on the transistor. So base current just small to on the transistor. So no need too large. So R2 is to limit the base current. State what happened to resistor of LDR when light intensity is low. When light intensity is low, means dark, like night time. Okay, resistance increases. Okay, okay, part D 2.2 shows transistor circuit. You are given three resistors R3 with resistance 50, 100 and 200 each. Calculate voltage across base emitter for each of resistor. Okay, this is VBE. Okay, let's say the first R3, which is 50 ohm. So VBE for 50 ohm. Let's say here is 50. So the voltage across R3 is smaller. So what is VBE? VBE means the voltage across here. Okay, so you want to calculate for that one. So we get VBE. Guna formula yang potential divider. Means 50 over 1000 plus 50 multiply 6. Means finding V3. So R1, R2, R3. So you want to find V3 means R3 over R1 plus R3 times total voltage. This is total voltage. Okay. Okay, so you will get VBE equals to 0.29 volt. Okay, part 2 is VBE for 100. So we have VE 100 divided by 1000 plus 100 times 6. So this one will get the answer. Okay, 0.57 volt. If 200, then VBE equals to 200 over 1000 plus 200 times 6. Okay, this one we get 1.04. Okay. Now look at E. The bulb lights up if the VBE is greater than 0.7 volt. This is junction voltage. To on the transistor, the base voltage must be greater than junction voltage. As you can see from the calculation above here, which one produce greater than 0.7 is 200 ohm. So means you need to put the resistor which is 200 ohm. Okay, so give reason of your answer. Okay, resistor 200 ohm. because VBE equals to 1.5 volt, able to overcome the junction voltage 0.7 volt. And transistor is on. Okay. Number 3, diagram 2 shows input signal and output signal when component X is connected. When connected X, you can see this is a half wave rectification. For half wave rectification, we just require one diode. So to convert AC to DC is process of rectification. So we need rectifier. Rectifier is diode. Okay. Convert AC to DC. Sorry, DC. Alternating current become direct current. So ini alternating, ini direct sebab one direction current flow. The name the component is diode. Okay, draw the symbol of component X. So we draw here. This is the positive, this is negative. PN junction. State the function of X as a rectifier, or to convert AC to DC current. Name one electronic component that can be connected to circuit to smoothen the output current. So it's capacitor. It will be charged and discharged. That's why it allows AC to flow through it. So we call it capacitor to smoothen the output current. But redraw the circuit with electronic component mentioned in 3A and 3B. Okay, lukis balik lagi sekali. Okay, so you have the input just now. So you put diode here, one. Then you put capacitor. Then resistor. Then this one output connect to screen of CRO. Okay, input AC, output DC. And then it becomes smooth out. First test capacitor. Okay, number 4, electrical circuit containing semiconductor diode. Diode. This one light up, this one does not light up. You can see the pole for the diode also reverse. As you can see from here, N negative, P is positive, so this is reverse bias. Check for this one, P connect to positive, N to negative, so ini ialah forward bias. Okay, what is meant by semiconductor? Is a material with electrical conductivity between a conductor and an insulator. Okay, B. Using diagram 4.1 to compare lighting of the bulbs and then current flow in the circuit, the way diode is connected to the terminal of battery. Okay. The bulb in 4.1 does not light up, tidak menyala. While the bulb in 4.2 lighted up. Okay. Part 2, current flows in the circuit. Bulb does not light up means no current. There is current flow in 4.2. The diode in 4.1 is reverse bias, while diode in 4.2 is forward bias. Okay. Okay, based on your answer, deduce relevant physics concept. The concept which is a connection, forward or reverse. The diode just allow current flow in one direction only, that is forward bias connection. Okay. Diagram 4.3 shows a full wave rectification. Draw the waveform of the full wave rectification. Okay, as we know, the full wave means negative also will be reversed. So it means like this. This is the full wave rectification. Okay. Capacitor placed across the output to smooth the current. So means it will become itu cantik. So this is the output current when there is a capacitor. I explained how capacitor used to smooth the current. When current flow, the capacitor will collect charge at its plate, and then when the current start to drop or reverse direction, it will discharge. Means it will supply current to the circuit. When current flow, in forward bias. Okay, charge. Bila ada current flow, forward bias, dia akan charge. When no current flow, current flow, in reverse bias, the capacitor will be discharged. Okay, section B. Diagram 1.1 shows symbol of transistor. So you look at here, this is PNP. Okay, so this is PNP transistor. Diagram shows circuit to amplify current. Microphone. State whether there is a reading in microammeter and milliammeter when S1, S2, S1 on, S2 off. S1 on, S2 off. Okay, no. Tak ada bacaan. Microammeter, milliammeter, okay, no reading because base circuit is off, transistor is always off. Okay, and then S1 off, S2 on. Same thing, collector circuit, there's no voltage. Okay, reading also 0. Okay, part 2, explain how circuit function as current amplifier when rheostat is adjusted and both switches are switched on. Soalan konsep. Okay, amplification factor, beta equals to IC over IB. Calculate current amplification. So IC equals to what? 1 milliampere, 10 microampere. Changed all to the number without prefix. Milli is 1 times 10 negative 3 ampere. 10 times 10 power negative 6 ampere. We get is 100. Means IC is 100 times bigger than IB. Okay. Okay, emitting current IE equals to IB plus IC. Okay, prefixes remove. We get 1.01 milliampere. Y and C, we calculate. Part C, diagram shows 4 electronic circuit W, X, Y, Z, different specification. So this one used to street lightning circuit, the most suitable, so that automatically on at night. Study the position of the LDR, connection of batteries, arrangement of straight line, and use of relay. Determine most suitable diagram to be chosen and give one reason. Okay. Specification given, position of LDR, connection of battery, arrangement of straight line. Okay, the use of relay to switch in the circuit. Okay, determine the most suitable circuit to be chosen and give one reason of your choice. You all boleh guna 3 kolom atau 2 kolom untuk jawab soalan ni. Saya pergi kepada jawapan. Okay, the first one, LDR connected at base circuit. So intensity of light is low, dark. Resistance of LDR increases, so V base is large, transistor is on. Okay, positive terminal of batteries connected to collector, so that transistor is forward bias. Okay, relay switch, so that secondary circuit will switch on, so that electromagnet will switch on the secondary circuit. So from here we can see E is chosen. Okay, so you can write this way or 3 column as I mentioned in my previous video. So this one just to make it fast, so I just show you the answer for this one. Okay. Okay, section C. Okay, diffraction of cathode ray, deflection tube. The difference is the voltage. What is the meaning of cathode ray? A beam of high speed or velocity electrons. Okay, state the charge of cathode ray, negatively charged. Compare voltage EHD connected to metal plate and deflection of cathode ray. Okay, VLT in A is smaller, should be. Relationship between voltage EHD and strength of electric field. When voltage of VLT increase, the strength of increases. Okay. The strength of electric field between metal plates and deflection. Okay. Strength of electric field increases. The deflection of cathode ray increases. Okay. Bagian D, fluorescent screen of multi cross. Ini ialah multi cross. Explain how shadow is formed. So ini yang 4 marks tu you kena explain lah, start daripada cathode ray, the cathode is heated and emits electron. the cathode ray gain kinetic energy travels at high speed. The cathode ray then hit the screen at the edge of multicross. Main travel at the edge of multicross, some of it will be blocked uh, by the cross. That's why we can see the shadow of cross on the screen. Okay. Kinetic energy of electron is converted to light energy. Okay. Okay. Create 4 sentence lah. Okay, ni lang. Last one. Suggest modification need to be done to the circuit so that can function as automatically fire alarm switch that needs high voltage, electrical component that are needed to replace any component in the circuit, position of this component in the circuit, electrical component that is connected to output transistor. So means we need the LDR, and then here we want to connect to a high voltage occurrence, so we need a relay, of course. Okay. So I show you the sample of answer, this one. Okay. Further. Nah. Thermistor detect heat when temperature is high. Bulb with siren to produce sound. Relay switch to output transistor. Interchange position of resistor R and thermistor to increase base voltage. Use the 240 volt power supply at the siren. Siren function at high voltage. 10 matang. Okay, so that's all. Thank you. Bye.